this video, let us understand the process involved in integrating using partial fractions. Fractions under algebra, I am sure you must have heard already. Consider the fraction p of x by q of x, where p of x and q of x are polynomials in x, provided q of x is not equal to 0. Degree of p of x, if it is less than the degree of q of x, that is, if the degree of the numerator is less than the degree of the denominator, then we call that fraction as a proper fraction. On the similar lines, if the degree of the numerator, namely p of x, is greater than the degree of the denominator q of x, then we say that it is a improper fraction. Now that we have recalled about the proper and the improper fractions, let us proceed with the integration process using the partial fractions. The nature of this integral is of the form integral of p of x divided by q of x into dx. And we can proceed with partial fractions only if the denominator is factorizable. Yes, so if the denominator is factorizable, only then we have the liberty to apply the principle of partial fractions. Now there are various types in which we can adopt this. So let us see them one by one. The type 1, the more convenient one, if the fraction is of the form px plus q divided by x minus a by x minus b with a not equal to b, then this fraction can be written in the form of a by x minus a plus b by x minus b. We'll have to evaluate what are a and b, substitute back, integrate, and then conclude the answer. Now type 2, here we have said a not equal to b. What happens if a is equal to b? It becomes x minus a the whole squared, isn't it? That is the type B. If the fraction is of the form px plus q divided by x minus a the whole squared. Now this can be identically equal to a by x minus a plus b by x minus a the whole squared. Now type 3 is, if the fraction is of the form px squared plus qx plus r divided by x minus a into x minus b into x minus c, then it is an extension of type 1 only. We can split it up as a by x minus a plus b by x minus b plus c by x minus c. The next type is, if the fraction is of the form px squared plus qx plus r divided by x minus a the whole squared into x minus b. So it's a combination. It's identically equal to a by x minus a plus b by x minus a the whole squared plus c by x minus b. The last type, if the fraction is of the form px squared plus qx plus r divided by x minus a into x squared plus bx plus c, provided x squared plus bx plus c is not factorizable. Now in that case, the fraction will be identically equal to a by x minus a plus bx plus c by x squared plus bx plus c. Now what if this fraction is factorizable? If x squared plus bx plus c is factorizable, then type 5 will turn out to be type 4 itself, and then we can proceed as usual. So we have seen the various types. Now we shall handle few problems so that we can practically see how well we can work it out using partial fractions.